Start. Good morning to one and all. This is Dr. P. Lavanya, working as Associate Professor in MBA Department in Institute of Aeronautical Engineering, Dundigal. Today our question bank relating to the critical analyzation questions of production and cost analysis. So in this first, we want to see relating to the a case relating to the production function with the combination of two factors inputs which are mutually changeable. So, discuss. So, here in the production function, as we know the short-run production function and long-run production function, in that here asking about what type of factors or combination of two factors where we can mutually changeable. Is it possible or not? So, first we'll see what is production function, what are one variable production function and also the two variable production function and how they are mutually changeable we can discuss in the below solution. So the first is the production function express the relationship between the input factors and also the output factors. Means it says that what sort of inputs we are utilized in the production, maybe like land, labor, capital and what type of amount or the goods and services we produced. So there assembles a technical relationship between both we can identify in the production function. So in this context, the production function which is having two factor inputs means whichever variables could be mutually changeable. So we consider in this scenario by considering or taking two types of inputs which could be substituted for one and another in case of production processes. So let us denote that there are the two inputs that is L and K where they represent L is the labor and K is the capital. So the production function could be expressed Q of that is a function of labor and capital where Q we can consider it as an output means where Q equal to the function of that is labor and capital. Where Q is the output, F is the function, L is the labor and K is the capital. Next, in this production function where we can technically express the relationship between the input and output factors. So, by this concept, we are able to identify that what are the mutual interchangeables which implies that one input could be substituted. Means we have taken two factors, labor and capital. So by mutually interchanging one factor for the another, we'll see that what sort of effect was there in the level of output. So this is often captured by the notion of elasticity of substitution. Means as we know elasticity means responsiveness or the percentage of the change in one fact to the another. So what percentage of this change we can identify in substituting labor for the capital where we can denote it by sigma. So this elasticity of the substitution is where we can identify in the percentage of the change in the ratio of inputs responses to the, as we can say like sigma equal to percentage of change in the ratio of labor and capital by percentage of change in marginal rate of technical substitution. So where we can say this rate that is marginally substituting one for the another at which one input we can replace with the another input which will affect the output. Means what sort of changes takes place in the labor and capital. Means substituting more labor, less capital or the less capital or more labor. One factor for the another where we are able to identify that what percentage of the change we are able to get in the marginal rate of technical substitution and which gets effect upon the output. So here we can say that these elasticity of the substitution, where we can say elasticity of substitution, indicate their high degree of substitution between the inputs and implying that they are more interchangeable. So once the substitution effect one for the another is high, then the inputs could be more interchangeable. And when these substitution of elasticity of substitution is low, means when it is high, the variables could be interchangeable in a higher quantity. But when these elasticity of substitution is low, which implies that the interchangeability one for the another is less. So there are some key points which we'll consider in this context for the production function, where we can substitute that mutually changeable inputs. So those are, the first one is, as we know, the Cobb-Douglas production function. It is the common production form of production function, and it is the function which take in the substitution of this quantity is equal to A of k, that is interceptable with k of b. Means where we can say that is q is equal to A into L sigma of k into beta. So where that A is in a constant and alpha is in a and beta are the outputs where we can elasticize with the labor and capital. Means here when you want to go for these elasticity of Q is equal to A into L, that is alpha into K into beta, as we can say A is in a constant factors. Alpha, beta are the output elasticities where they represents the substitution of labor and capital. So these are considered in case of interchangeable in case of Cobb-Douglas production function. And this we can identify in the elasticity of substitution. Already we have identified that elasticity of the substitution is a crucial parameter which help us to identify that interchangeable of the elements, maybe the labor and capital. When this elasticity of substitution is high, the interchangeable will be more. And when this elasticity is less, then interchangeable will be less, which leads to the what sort of percentage change in the inputs, where we are able to identify the percentage of change in the MRTS. Means here we can calculate this substitution like a percentage of change in inputs by percentage of change in marginal rate of technical substitution. So the next another factor which will influence in case of interchangeability of the two factors is isocont, where they represents the combination of inputs and produces the same level of output. As we know, isocont means equal quantity and isocost means equal cost. So these two inputs where they represents the combination of inputs at a same cost, means isocost means at a same cost we can combine the different types of inputs. So the slope of this isocost is a negative to the MRTS, and the slope of isocont is the negative of inputting the pricing ratios. Means through isocost and isocont also we can represent this marginal rate of technical substitutions by saying that equal quantity at equal cost we are able to identify where the organization is getting MRTS. But in case of isocost and isoconts, we are able to identify the negative slope of these marginal rate of technical substitution. Next, another factor is cost minimization. So the firm always aims at maximizing the cost and producing at a given level of output. And the scenario, mutual changeable input, the firm will choose the input combination that minimizes the cost and take into the account relatively price of the inputs. Means the firm itself will minimizes while producing a given level of output. So we can say that the interchangeability of the factors we can identify with this combination, the organization or the firm was able to lessen the cost taking the consideration of prices of inputs. Next, long run and short run curves. In the long run, the firm is having more than 5 years, lot of periods, so where it is more flexible and adjustable such that it inputs mixes the potentially and leads to the high degree of substitution between the labor and capital. Means more time will be there and they are flexible whatever the extent based upon the demand or based upon the external marketing conditions. We can change the production and potentially we have a high degree of substitution between the labor and capital. But when you comes under the short run, we are unable to go for the flexibility as the period is very small, maybe like 6 months or 1 year. So there the flexibility or changeability of labor and capital was only limited. So by taking the above different types of factors relating to the two factors variables where they can be interchangeable. So these production functions and the degree of interchangeables having the crucial impact upon the inputs and the optimum decisions regarding the usage and the cost minimization. So we can say that velocity of substitution which plays a key role in case of determining the nature of this relationship. The next question we can say like demonstrate the output relation among fixed inputs and variable inputs. So here what are the fixed inputs in the cost in the production analysis and variable inputs and what sort of relation was existed between these two with the help of factors we can analyze in this question. So the first we can say the relationship existed between the fixed and variable inputs is often we have illustrated in the cost of production function. As we know the production function itself shows that maximum quantity of the output where the firm produces with various combination of inputs at a given level of technology. So as we can hypothetically we know that it is the production functions or the Cope-Douglas production function where it will says that how much maximum quantity we can produce by minimum utilization of the combination of inputs. So where we can say that Q is equal to the function of capital and labor K and L, where in this Q is the quantity of output, where K is the fixed inputs in case of capital, L is the variables where we can say like labor. So in this production function, one is fixed like capital and another is labor is a variable factor. So in this scenario, the firm has an amount of fixed capital maybe like machinery and building where they can denote it by K and it is varying among to the labor to produce the level of quantity. Now we look into the three types of scenarios where we can demonstrate the output relationship among fixed inputs and variable inputs. Means fixed where we call it as capital, variable input is we'll call it as labor. So we'll consider those three parameters like one is increasing labor. The first one is the variable input will be increased. If the firm increases the amount of the labor while keeping the capital as a fixed, the output Q is likely to increase, showing a positive relationship between the variable input and output. Means the amount of the capital is fixed by considering the cheapest labor giving a less amount, we go for increasing of the labor. Once the labor was variable and increasing, where we are able to identify that a positive relationship between the inputs and output. And the second condition is decreasing labor. Means variable input will be decreased, amount of the labor and output K may be decreased. Once the labor decreases, the output will decreases, which depends upon the variable input for the production, shows the negative relationship. Once the labor has been decreased, the variable one, automatically total production will also decreases. Next, the third one is the fixed inputs. So regarding the interchangeability of the labor may be increased or the decreased. Now we'll see the fixed inputs like capital remains constant. This reflects that the concept of fixed input do not change in the short run. Means in the short period of time where the time is very and less and limited, so where we are unable to change the any factor. So this concept is very much useful in case of short run. So in order to have the specific shape of the production function, this curve will be depends upon the nature of the inputs and also the technology using the production process. So the common production function shapes including the linear increases upon the returns of the scales and a decreasing returns to the scales. Means here the dependability of this increase or the decrease of these production or the production functions by considering one factor as a variable and another as a fixed, we are able to identify that having a linear or increased return to the scales and a decreased returns to the scales. So finally or concluding we can say that there is an output relationship, means compulsorily a positive relationship will be there among the fixed inputs like capital and variable inputs like labor are there in case of short run and long run production functions like law of variable production and law of returns to the scale, which are much more fundamental concepts in economics, and these production functions will provide a tool for analyzing the and understanding the relationship between the inputs fixed and variable inputs in the production. Next, demonstrate the ratio of MRTS between the capital and labor shows in graphically. So already we should know what is the marginal rate of technical substitution. We want to demonstrate and how it was taking place between the fixed factor like is capital and variable like labor, and which we can analyze in the graphical situation. So first we will see what is marginal rate of technical substitution. So this is the substituting one factor for the another, where the organization will get the least cost combination, or where the substitution will yields as the cost is less and output is more. So how these substitution could be takes place in capital and labor, in measuring the rate of capital could be substituted while remaining the same level of output. So this could be defined by which the amount of the quantity of the capital to be reduced by adding the additional unit of the labor and is employed by keeping output constant. Means one is substituted for other. Means labor was removed by capital, or capital will be removed by the labor, but whatever the output should be the constant. So here marginal rate of technical substitutions we can express and the ratio of marginal productivity of labor, which we'll call as MPL, marginal productivity of labor, and marginal productivity of capital, MPK, where we can say that marginal rate of technical substitution for labor and capital is equal to marginal rate of productivity for labor is divided by marginal rate of productivity for capital. So now consider hypothetically a production function where we can see that Q is a production output and both K is the capital and L is the labor. We can demonstrate a production function saying that Q is equal to function of K and L. So where we can identify that a graphical representation in the production in case of isocont. So where we know the isocont itself shows the different types of combinations relating to the capital and also labor, which gives at an output level. So here the MRTS is equal to the slope of these isocont at a particular point. So here we are able to see here what sort of the marginal graphical representation of this marginal technical substitution. We can say that where the capital is denoted on the x-axis and also labor is taken on the y-axis. So when we on substituting one for the another, we are able to identify that when the labor was at 12 points, we are able to identify more labor and a less capital. More capital within a less labor. But once the capital decreased, we are able to analyze the increasing of labor. When the capital was at 8 points, we are able to identify the labor at 2 points. When the capital was at 4 points, we are able to identify at 3 points. Means once this substitution, marginal rate of substitution, as the capital decreases, and we are able to identify that increase in the labor utilization, which was giving the maximum combination, shows that this marginal rate of technical substitution is itself is diminishing. But when you say this curve, it was unable to get the combination, showing that in case of utilization of 6 units of the capital to the 3 units or the 4 units of the labor, it was diminishing, and it goes on decline, shows that more availability or increasing of the labor by displacing or removing of the capital gives the negative result. So we must and should have the optimum, means we should stop at the point where we are able to get these optimum cost at 6% of labor. We are able to identify that 3 units of labor is possible, means capital and labor. Graphically shows that as this marginal rate of technical substitution help the production to identify at where the organization is able to get the least cost combination, showing that where the cost is less and output to be maximized, least output to be maximized. So, in this way we are able to identify this graphical representation of these marginal rate of technical substitution by considering the labor and capital as two important factors. Now, formulate an example in order to show how innovation plays a key role in the global environment. So, in case of production and distribution or maybe the pricing strategy, every organization is to be exposed to the external environment. So, innovation plays a globally an important role. So, with that we are able to identify a small example how this innovation is very much important in case of organizational growth or the key role in the global environment. In this case of innovation, as we know that renewable energy resources, means innovation has been done in the renewable energy, such as where doesn't cause any sort of pollution and where they can be reused and freely available. So these are called as renewable energy sources like solar and wind power, where they are playing a crucial role in addressing the environmental challenges. So worldwide, every country want to improve its key renewable energy sources, as they are much more required for the welfare and also the productivity purpose of at national and international level. So already traditionally what we have the electricity production through coal and other, which are causing a lot of environmental disasters, and also the sustainability of the environment has been damaged. So in order to control this environmental pollution, so the different international organization came forward and came within a renewable energies, where with the solar, wind and other. So where we can address it is in one of the environmental challenge where all the countries are facing it in a international level. So traditionally, as we have these energy sources like fossil fuels, and which attributes to the air pollution and also the greenhouse gas emissions and climatical changes. As we are saying, the present climatical and pollution changes is normally taking place due to these fossil fuels and others which are traditionally used, and they themselves are causing a lot of environmental pollution. So these development and implementation of innovation and the technology in these renewable has a significantly reduces the environmental impact upon the energy production. Means by the solar and the wind power or another renewable energies, the environmental impact of pollution was reduced, and as we are able to identify that the advance in solar panel efficiencies and also the energy storage will be accessible and reliable. Means with the help of the solar grids, as we know that advanced panels has been innovatively produced. Because of that, the energy could be stored under this grid management system of the solar energy has been more accessible and reliable. Here similarly, improvement in case of wind turbines where they designed and manufactured and increase the efficiency and affordability of the wind power. Means traditionally we have only the limited scope for solar and the wind power energies. But by an innovative technologies at an international levels and the national levels done, by their efforts, we are able to identify an improved and efficient solar panels and also wind turbines where they designed in an efficiently in order to go for these more innovative storage of these energies. So these innovation has placed a substantially decrease in reliances or depending upon every country relating to these foil based electricity generation where they are emanating a lot of pollution to the different and causing different environmental effect. So by these innovative techniques where we can say the globally they adopted many countries and the many nations have taken the challenges relating to the renewable energy technologies and they mitigate that environmental impact of these energy production. Means by considering these solar and the wind energy, they themselves will decrease the pollution upon the environment. And also, this has been created more sustainable and reliance energy in case of infrastructure. So here, due to these adopting of these renewable energies, where there has been decrease in the carbon emission and lowering of air and water pollution, which helps in the combat climatic changes at a global scale. Means in case of at an internationally, due to these energies, the air, water and carbon emissions in the climate or environment was decreased and which helped for to sustain a good climatic conditions at a global level. So by this we can say that illustrating an example relating to this renewable energy by innovative methods, means by taking innovation as a basic research program where we can emerge the energy in a positive impact and help for the global environment where they provides for more clear and sustainable alternatives in case of these traditional energy sources. As we know the traditional energy sources they themselves involves lot of pollution, creates the environmental impacts and hazards. So to remove that one, the globally the technologically or innovative methods are used in creation of these renewable energies in case of solar and wind, which helps to protect the environment and sustainability at a global level. So these are the some of the important questions relating to the cost and production analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.